All right, cool. So I'm going to go through my example with my data, and then you guys will be able to do yours. So what I want you guys to do is take the golden piece of paper out, because that's where I'm going to be writing. So that way you guys have an example. The pale yellow is your practice one, and then I'll give you guys some more practice questions as well. Cool. So everyone should get the gold one out to copy down the notes. All right. So first thing we got to keep in mind, I just want to copy down this data, which is just an estimation of the ratio between my undiluted sour cream. So that is my acid and also my unknown in this set. And then the sodium hydroxide, which is at 1 mole per liter. That is my known, and that is my base. We good to that? All right. So I am taking 1 ml of my sour cream, which is my acid, and I want to see how many mils of the sodium hydroxide I need to add. So what I'm going to do is I'm just going to move this out of the way. We're going to do an actual example. So I put 1 ml of the purified sour cream, adding a couple drops of my indicator, which is spheno, which will turn pink in a base. And then here in my other beaker is my sodium hydroxide. So I'm just going to go mil by mil, keeping count. So that's 1, 2, 3, 4, sorry, it keeps blinking, 5, 6, 7, 8, 9, 10, 11, starting to turn. Oh, I'm running out. 12, need to get some more base. It is okay if my number does not match your number, because this is just a rough estimate. I have enough. All right, what did I say was on 12? 12. Here's number 13 coming up. 13, starting to turn pink. 14. Oh, it's a nice pale pink. Is it going to stay though? Nope. Changing colors. There's 15. It's a nice pale pink. So when you guys are doing your titrations, this is the pale pink that we're trying to get when you guys are doing that, just FYI. I'm just making sure it holds. It's holding. All right, I'm happy with that. So from that information, I've given myself a rough ratio of 1 mil of my sour cream is going to need 14 mils. Did I say 14? Yeah. Or did I say 15? 15, thank you. 15 mils of my sodium hydroxide. That's a 1 to 15 ratio at this point. Are we okay with that so far? All right, so let me show you guys how to do your calculations and what sort of things that we are looking for. So I'm actually going to write this up to a merit level, because usually the mistakes then mark you down from a merit to an achieved. So just FYI when you guys are doing the work for this. All right, so some things to keep in mind is that I need to gather information about what equipment that I have been provided so I can think about what I could do dilution-wise. So we need to read through my teaching example. So they're saying that, you're carrying out a practical investigation to figure out the concentration of the lactic acid in sour cream. And this is just a list of all the things that we're doing. So we're trialing and modifying the procedures. This is part A. We're calculating concentration of our standard solutions to verify concentration. We're collecting our own data. We're reaching a conclusion from that data, and then we're also doing an evaluation on it. So there's part A, B, C, and D. We're only focusing on part A for today. All these little ones are going to give you some background. So in this case, we're talking about sour cream. The lactic acid is added to give that sour taste. Depending on that sour cream, it ranges as roughly 0.055% when you have sour cream and you're measuring the lactic acid in there. Now, just as an FYI, during the purification process, we have concentrated down the sour cream. So our lab technician has said that the amount of lactic acid we should have in our purified sour cream sample, the one that I gave you, should be about 11%. And we're comparing to see, is that a correct value? So that's what we're double checking. In order for us to check the concentration, we're going to be using stoichiometry. So we're using the concentration of the amount of sodium hydroxide, and we're checking against the lactic acid amount. So this is the equation that we've been given for that. We will use those equations when we're starting our calculations for part C. And then they give us a list of all the equipment that we're using. It's the standard stuff that you guys would be expecting. The main thing that we need to keep in mind with our trials and things like that, or with our experiment, is the size of the pipette we're being given and the size of the volumetric flask that we're being given, because that then determines how much we can dilute our solution by. So the main thing I'm looking for here is that it is telling me that we're given a 10 mil and 25 mil pipettes. And the volumetric flask that I'm being given is 100, or I can use 250 as my two choices. Are we okay with that so far? All right. So when I go here, they want me to just make a copy of what sort of things that I said. So what size pipettes do I have? 10 and 25. So I have a 10 mil pipette, and I have a 25 mil pipette. What size flask do I say I have to work with? 100 and 250. So the next thing I then think about is, what are my possible dilution factors? So if I have, for example, a volumetric flask, like this guy here, what happens is I take my pipette with my undiluted stock, and I add it to a volumetric flask to dilute it. So I'm taking this, I'm adding it to here, and then I fill it up to the mark to then dilute it. So there's lots of different options. I can take my 10 mil pipette and I can put it into 100 volumetric flask. That gives me a 1 in 10 dilution, also known as tenfold. So it's 1 part of my sour cream, and then it's 9 parts water. So a tenth of my solution would be the new dilution of it. Are we okay with that so far? All right, my other option could be, I could do 25 into 100. So what's that if I simplify that ratio? 1 to 4. So that's an example of 4-fold dilution. I could also do 25 into 100. So what's that going to be? 1 and 2? Sorry, 25 into 250. Tenfold again. And then my last option is, what am I doing? Oh, 10 into 250. So what's that? 1 and 25. So that's a 25-fold dilution. Are okay with how I've done that? Yes, no? Right, so those are my options with the dilution. Now what I need to figure out is what is the possible values that I get. Come on, calculator. Sorry. Usually my calculator works. I don't know why it is not working right now. There we go. Okay. Cool. All right, move it over. Is it too not bright enough? Dark enough? Better? Okay. All right, so that's my data here of my possible dilution factors. So I can do 10-fold, 4-fold, or 25-fold as my three options. Now let's talk about how I do the calculations. So right now, if I was thinking about my current setup, so if I don't dilute my sour cream, I would have the smallest pipette I could use for titration is 10 mils. So if I use 10 milliliters of my undiluted sour cream, how many mils of sodium hydroxide would I need for that? How much? If I know 1 mil of the sour cream needs 14 mils of the base, 10 mils of sour cream will need how many mils of base? 140. Is that going to work? No, because then I have to basically fill my burette at least 3 times every time I do a titration. So I need to dilute this guy down. So basically what this says is that this here is coming out of my pipette. This is coming out of my burette as the titrate volume. And that's way, way too high. So what we do is we do a calculation where we take the titrate volume, which is in milliliters. So this is basically what comes out of the burette. I can estimate how much of that I will need if I do some math. So what I can do is I take the aliquot volume. Now of the aliquot volume, we are referring to out of the pipette. I multiply it then by the desired ratio. Divided by the actual ratio. So I can figure out an estimate of how big my titrate volume is going to be. So that actual ratio that we're talking about, that is the one that you guys have gotten experimentally. So in this case, what did I get as my experimental value? 1 in 15. So 1 divided by 15 is that number. The desired ratio are the list of the possible dilutions I can make. So say, for example, the 4-fold dilution, the 10-fold dilution, the 25-fold dilution. Are you okay with that so far? All right, let's show you guys how to do the math. So what I like to do is I personally like to set up a table. On this side of the table, I'm going to be putting my 2 pipette options. So I could have a 10 mil aliquot or a 25 mil. So those are my pipette options. Then on this side, I will have my dilution options, which is what I figured out over here. So I have 4 different choices. I have a 4-fold. I have a 10-fold. And I also have a 25-fold as my 3 choices. Are we good? All right, keep going. All right, grabbing my calculator. So the way this works when I'm plugging this in is that the aliquot volume, I'll grab some more color so you guys can see where I'm getting these numbers from, is the pipette options. So these guys here go into the aliquot volume. So I'm going to do 10. Turn on. You were just on. Get some new batteries for this. Otherwise, I'm just going to grab another calculator. No, we're not going to work for me today? Okay, fine. Don't do that. Okay, I'll just use this one. Okay, so what I'm going to do is I'm going to do 10, because that is the volume of the pipette that I'm using, the aliquot. I'm going to multiply it by, and I'm going to use parentheses. And parentheses are going to be really important so that way we can make sure that I have the order of operations correct. So what goes on the top is my desired ratio. So the desired ratio is going to be the list of the possible dilution factors. So this list here. So these guys are that number. So let's do the first example, 4-fold. So that's 1 in 4. Close brackets, and I'm dividing it by my actual ratio. So my actual ratio is 1 in 15. And then I'm closing the brackets, I hit enter, and what that tells me is that if I was to do only a 4-fold dilution, and I was doing 10 mils of that full 4 dilution, when I do my titration, I would need 37.5 milliliters of my sodium hydroxide from my burette. That's what that's referring to. Again, do the same calculation, but in this case, the only thing I changed out is that instead of being multiplied by 10 as my first step, I'm multiplying by 25. Use the double brackets. Desired ratio, we're doing 1 in 4, divided by the actual ratio, which I have as 1 in 15, because that's from my experimental setup. And if I was to do 25 milliliters of the diluted solution, that's 4-fold, I would need to have 93.75 milliliters of my titrate coming out of my burette. Which makes sense. I'm using a larger volume of my undiluted solution, so I would expect it to be more. All right, and then we just keep doing the same thing, working our way through. So in this case, I'm doing 10 times, close brackets. In this case, I'm doing 10-fold as my desired dilution, so 1 in 10. Dividing it by 1 in 15, which is what my actual is. And what I get is that this one is going to be 15 mils. Can you guys see that okay? Or should I make that a little lighter? There, now you can see the calculator. Yeah. Oh, it's the blinds. What was it? The other one. Is that bad? You get the one close. Further down. Better? All 3 of them? That's fine. I'm going to take it here too. Yep. I'm tangling before I do this. any better? I'll sort that out later. All right. Okay. Anyway, I'm going to change this number up here to 25 now, because I'm doing this one here. So all I'm doing is changing the volume. This is going to require 37.5 milliliters. And then this last one here, switching that back to the 10, changing this guy over here to 25, because now we're doing a 25-fold dilution. So if I take a 10 mil of a 25-fold dilution, I would only need 6 mils of the sodium hydroxide. If I took 25 mils of that, I would then need 15. So that's how I'm getting those numbers. Do you guys need me to put the calculator back up? So this number here represents the aliquot volume. This number up here represents the desired dilution, the desired ratio of my dilution. So these guys over here, depending on which one I'm doing. And then this last bit here represents what you did experimentally. So experimentally, I got 1 and 15. So I'm just trying to get a rough estimate of what my titrate volume is going to be. So what's going to be the amount coming out of my burette? Based off of different dilutions, based off of different amounts of the dilution. All right, keep going. Keep going? Okay. So what I need to be mindful of is from this table, I need to find things that are going to be appropriate. So when we say appropriate, or that's acceptable, the range that I'm looking for is somewhere between 8 and 25 milliliters. 8 and 30 milliliters, in order for that to be an accurate titration. Ideally, if I'm trying to aim for the excellence and I want to get a really good value, I would want it to be between 10 and 25 milliliters coming out of my burette. So basically anything that is within that range, I will accept. So when I'm looking at this, 37.5, that's too high, so I don't want to use that one. This one here at 93, that's definitely too high because now I have to refill my burette, so that one's out. 15, that falls within that range. I could use that one. This one here, 35.7, too high. This one here, 6, too low. The titrate volume would be too small, so won't use that one. And then this one here, 15, I could also use. So basically, these two are the acceptable values. So what that tells me is that when I propose my procedure, I can select either of those two, and I would be correct. There isn't one that is necessarily better. Are we okay with that so far? All right. So then what I do is I fill in my proposed procedure. So I'm explaining what am I going to be doing and why. So from my original solution of household sour cream, I have to make a decision on how much I want to dilute it by. I'm going to use tenfold because I find tenfold to be the easiest. So I'm going to say I'm going to do a tenfold dilution. And from that tenfold dilution, I will take 10 milliliters of that aliquot. So 10 milliliters of that sample. The next step here explains how I'll be doing that titration. So I'm going to be referring back to this page over here and how I'm going to do it. So there's two choices in how I make a tenfold. Either I do 10 into 100 or I do 25 into 250. Again, either option is correct. So what I'm checking to see is your procedure making sense for what you have gotten? I'm going to do, I'll do 25 into 250 in my example. But if I selected 10 into 100, that would be fine as well. We good? All right. Then for the actual titration with sodium hydroxide, I'm going to take 10 mils of the diluted aliquot. So basically this number and this number should be the same number because we're talking about the aliquot of the diluted solution. With the household sour cream, I'll add a few drops of the pheno indicated and titrate with the standard sodium hydroxide until the color changes from colorless to pink. This tells me that I have a predicted average titrate volume of approximately, and then I look back up here for the number that I've selected, 15. So it's explaining my proposed procedure. That's what we gotta do. All right, so that is a merit level answer if you have been able to do all that. If you make a mistake somewhere, that then marks you down to achieved. So there's several different ways you can be marked down to achieved. The first way you can be marked down to achieved is if your dilution factor is incorrect. So you make a mistake here. That can bring you down from an M to an achieved. The other thing that can bring you down to achieved is, let's say you choose something that isn't a good dilution factor. Let's say you choose something that isn't within that 8 to 30 range. So that's the other place you can get achieved. So that's how we get, again, from M to A. Now, keep in mind with this assessment that your grade is based off of your lowest section. So part A, part B, part C, the lowest grade you get on one of those 4 parts is going to decide your overall grade. Now, keep in mind there is a little bit of forgiveness here and there. So like, for example, for part A, if you don't do a good job with it, you can still manage to make up that work in part D. So do keep that in mind when you guys are working. Right, we okay with that so far? And don't worry, we have lots and lots of practice problems. Okay, so that's what you need to do for the merit. For the excellence, you need to justify your procedure, which is this bit here. So with that justification, what I'm looking for is your reasons why you have selected your procedure. Now I'm just trying to figure out where my pens went. There we go. All right, so first thing I would talk about when you're trying to justify it is talk about your initial ratio. That way you can explain why you need to do the dilution. So first thing you should do is explain why you need to dilute. So from my initial ratio, it was 1 in 14. So if I was to actually do this for titration, I would have 10 mils, sorry, not 1 in 14, 1 in 15. I would need 150 milliliters of my sodium hydroxide, which is too much. So that's too large. What I ideally want is something between 10 and 25 as my titrate volume. What you need to then do for the excellence is you need to explain why is there an upper limit and why is there a lower limit. So my lower limit, this 10 mils, and obviously you guys are going to write this as a much better paragraph than I am. I'm just doing it shorthand, is because of the percent error in the burette. So we're just talking about the burette error because the burette isn't perfectly accurate. The burette has an error of about 2%. So we're trying to think, okay, how much does that 2% affect my results? So when we're talking about, say, a 10 milliliter sample, and we have a 2% error of 10%, so that would be 0.2. If I multiply that by 100, the error in a 10 mil titrate volume will be 2%. Now let's look at what I selected. In my method, what was my titrate volume for my coming out of my burette? If I look at my instructions, I said it was 15. So if I have 0.2 divided by 15 times by 100, let's see what that error would be. So 0.2 divided by 15 mils times by 100. So my error then would be about 1.3%. So you see how the larger my volume is for my burette, the smaller that 0.2 mils has an effect on there. So if I chose something that was 0.6, I'd have a higher percent error in my my titrate volume. So that's why I want to select a value that's between 10 and 25, so that's my lower limit. Anything below 10, you could probably get away with 8. It wouldn't be an excellence level work, I would say, but that's what we're looking at. All right, upper limit. So why am I limited to 25 mils of solution? First off is that I want to limit the amount of times I have to refill the burette. Because we know that every time I refill the burette, I'm going to introduce potential error. I forget like my funnel and things like that. Or I misread the marker. I ideally, if I did 50 divided by 2, if I have a titrate volume of less than 25, I can basically get 2 titrations out of that. It's more efficient that way. The other thing I need to be mindful of is waste. If I use more than 25 mils, I'm using quite a bit of solution for the titration. So that's why I have my upper limit. So like if, for example, in theory, you could use the 37.5 milliliters as a titrate volume, but the problem is you're going to have to refill your burette each time you do the titration because there's not going to be enough solution to do it twice. It's also going through buckets, so we don't really want to do that. This one here is problematic because that's refilling it in the middle of the titration, so I can't do that. All right. The other thing we can think about is an explanation to my diluted of my solution. So explain the number of trials you can do. So when I'm looking at my example, I said I was going to take, I was going to make a 250 mil dilution. Ideally, you want to make the dilution once. And the reason why is because each time you make the dilution, there's going to be slight variations. So if I can dilute my solution once and use it for the whole experiment, that's better than me diluting it, realizing I need more solution, and then doing a new dilution, because there's going to be slight variations with each one. So ideally, I only make a dilution once. So that way, it's consistent. So basically what I want to do is I want to check. So if I do 250 milliliters of my stock for my dilution, and I'm only using 10 mils each time I do a titration for my aliquot, how many experiments can I do? 25. So I can do 25 titrations, which means I can get quite a large sample size. What if I only did the 100 mils like I had as my other option? If you guys remember, we looked at this guy over here, there were two ways I could make it tenfold. I could also make it as 100 mils. So how many would I only get? 10. Do you think that'd be enough? Probably. You could probably get away with it because you're factoring in I need to do 1 rough titrations and 3 accurate ones. So I need to do at least 4 titrations in order to make sure I have my data. 5 if I want to be on the safe side. So I needed probably about at least 50 mils. I could get away with 100, but if I needed to do, say, more than 10, I would have to make a new dilution, and that new dilution would be slightly varied compared to the original. So ideally, I wouldn't want to run out. So usually, depending on what you're doing, you tend to want to make more. But the downside to making more is that I use more of my original stock. So I don't have as much left over. So there's pros and cons to each one. Nothing is perfect. All right. That's what I need to see for the excellence. I need to see a justification. So you should be talking about why you need to dilute. You should be explaining to me the lower limit. You should be explaining to me the upper limit. And you should be explaining to me the number of trials, just to see that you guys understand what you're doing and why you're doing it. Cool. All right, what questions do you have? The good news is if you muck up this part D, you are given a second opportunity to kind of clean it up. Okay? All right, so just mindful of the time. We have 5 minutes left. Do you guys want to have some chill time? Or do you want to keep working? Keep working? Save the time. How much time you guys got? 65 minutes? You got 70? You basically almost have a session free if you guys want to have a session off. Cool. So, tomorrow, I'm guessing you guys just want to sit and practice calculations? Yeah? All right. So what I'll do is I'll hold off and give you guys the practice version of part A. We'll do that when you guys get back next term because I want to make sure that it's a nice little refresher. What I will do is I'll pass out the practice questions. So these guys here are just the same as what you guys have done, except I've given you guys the ratio. So it's all a dry version, but the calculations work the same way. The way I've designed these guys is it is double-sided. And what you can do is you can rip off the questions once you're done. So if you aren't done with the whole packet, but you are done with question 1 and 2, I want to mark question 1 and 2 like sooner rather than later so you know if you're doing it right or wrong. So you can rip it apart and hand it in to me. Okay? Tomorrow I'll let you guys have as time to get some work done. Okay? Like I said, I try to keep it on different colored paper so you know which set is which. So you guys can swap the pen over sign, but I find this is actually a lot worse now that we started seeing math. You might want to move back to science. So you're yeah.
Thank you.
So, I'm looking for you guys to get the pale yellow one done and the green one done. There's no rush though, because we'll be this up next time. Right. So you want to save your preferred activity time? Okay, and you're working. Did you guys want to have I don't see you guys on Thursday, Wednesday. I don't see you guys on Friday. Do you guys want to have your preferred activity tomorrow? Is it for you, or do you want to save it for next term? I know, that's what I'm saying. Because this one Friday. So we either do work on this tomorrow, or we just figure tomorrow. You guys can have a little thing. Yes.